Well, good afternoon. It is Thursday, February the 4th. We're here at Advanced Level Chemistry at Spain Park. Today I want us to go over, you should have done the odd ones for homework. It should already be done. If you haven't turned them in by the time you're seeing this video, by the time the video is released, then you're going to be out of luck for this particular assignment. Okay? But the good news is you're going to get to do the even ones also. So, how many of y'all right here would bet me a nickel that you got all of these right? Or at least you would have made, if I graded this for accuracy, you'd make an A on the paper. You think so? I got one that's saying yes. No? Two saying no. All right. Listen. If there's anything you don't understand, y'all tend to be quiet. Speak up and ask me the question. Let's figure it out, okay? So, I highly recommend as we're going over this, you go ahead and have that ion sheet out that I gave to you, so you can just kind of be looking and seeing the names of the ions as I'm going through and doing this. Okay? Now, Madison, I know you did all of it on your computer, right?
Okay, no, I didn't.
Oh, okay. So, I want you to stay focused here, so I don't want the computer to be a distraction. Okay? So, if I'm going to write the formula for potassium and iodine, what do? What's potassium's charge going to be?
+1.
So I write the symbol and charge, potassium +1. And how do I know that that's going to be +1 just without any memorization or whatever? Because it's in that first column, it's an alkali metal, right? We know all of those are +1, so you don't have to memorize any of that. You just know what it is. Okay? Iodine. What's iodine going to be when it's in the ion form?
-1.
I-1. And how do we know that?
Because it's a halogen.
Because it's a halogen. Therefore, the formula is simply going to be Ki. Now, you can leave it like that, I don't care. But typically, you just don't have the charges. And if you can do it in your head, +1, -1, you don't have to show that. You just need to get right. It's just the charges. I put the charges so you can make sure you see why and how we're getting what we're getting. Okay, so number 3, sodium. Olivia, what's sodium's charge going to be? +1. Okay? And what's sulfur's charge going to be? 2-, right? So what's the formula going to be?
Na2.
Na2, we're going to crisscross, we're going to bring that there. We don't have to write the 1. It's going to be Na2S. Okay, now again, that's all you need to write is right here. If you can do that in your head and whatever, I'm just trying to, again, be overboard with the explanation. And finally, number 5, aluminum and nitrogen. What's aluminum's charge going to be?
+3.
+3. And again, you look at element number 13, you'll see the little number 3 above the symbol. That tells me that it's a +3. But all family 13, boron, aluminum, gallium, are all +3. Okay, so alkaline metals are +1, alkaline earth metals are +2, boron family are all +3. Now, in terms of negative charges, nitrogen, oxygen, fluorine, -3, -2, -1, always. That's the only possible negative oxidation states. I went through and showed you that they can have positive oxidation states a bunch of different ways because of the way it bonds with oxygen, because oxygen will shift and arrange and do that. So, but the only possible negative ones, and most of the time the non-metal is written last, the only negative ones are -3, -2, -1. Those are really the only ones you need to be worried about. So aluminum is +3 or 3+. Nitrogen is going to be 3-. So what do I have to do anything? No, because the whole point is for it to equal 0. So my formula would just say ALN.
Can I unsubmit my paper to fix things that wrong?
If you got it wrong, yeah. If you already submitted it, that's fine. Now fix it. Does it change? It doesn't change it on what you submitted, does it? I don't think it does. No, definitely correct it. All right, so that's just straightforward there. So far, it looks like you guys are doing pretty good. Now we have to write the formulas for a little bit different one. So we'll start with number 7. So what does this Roman Sam? What's that Roman numeral tell me?
That's the that's 2 plus. It's like what the
2 plus
states
on
in-
which element?
10.
On the 10. It's always on the metal. Okay, it's always on this first thing. So 10 is going to be 2 plus. And what do we know oxygen's going to be?
2 minus.
2 minus, always. So therefore it's SNO. So, Madison, what's ammonium? NH4 plus. Okay, and that's just one of those, that's the only, again, positive polyatomic ion. You just look on your sheet for ammonium. It's at the top. Okay, and then sulfite, because it has ite, what other element do I know is present?
Oxygen.
Oxygen. Okay, but you don't know how many, but I do know that I look at sulfate has SO4, so sulfite's going to be SO3, and all sulfur compounds have that 2 minus charge. So I have a plus and a 2 minus. What do I have to do?
It's put the 2 subscript around NH4.
You have to have a 2, this 2 is going to come to here, okay, and the 1's going to here, so we're going to end up with NH4 2 SO3. It's all that on the screen. Are we good with that? Notice we only use parentheses with polyatomic ions. There's no parentheses on monatomic ions. Only when you have more than one polyatomic. I don't need a parenthesis around this because it's only one. All right, so 11, cobalt 2, again, a Roman numeral 2. So, Olivia, tell me what we get on this one. What's the final answer that you got? COO. Okay? Because CO is 2 plus, O is 2 minus, so it's just going to be COO. Sam, what you get for 13?
Ca3N2.
Okay? Now, how do we, why, that is exactly right. Ca3N2. How did you get that?
Calcium is +2 and nitrogen is -3.
Nitrogen is always going to be -3, so you just crisscross. And you end up getting the Ca3N2. Does everybody see on the crisscross? All we're doing is finding the lowest common multiple. 2 and 3 goes to 6. All right, so far everyone's shaking your head, feeling like you're getting this. Lead 4, you got to practice your Roman numerals. You got to know that that's a 4. Okay, so if you don't know your Roman numerals, you need to learn them up to 6 or 8. Okay, know the V is 5. When the 1 is before it, that means 1 less. It's after it, it's 1 more. Okay, and so even the Super Bowl. This is Super Bowl 54, and so when you're looking at it, it's going to be, that's 50, so it's going to look like this. That's going to be 54 for Super Bowl. I always do the Super Bowl in Roman numerals. L is 50, 1 before the B is a 4. Okay? So we're going to say, what? What's the symbol for lead? PB, and it's 4 plus. Carbonate, you look on your sheet and you see that carbonate is CO3 2 minus. So do I need to crisscross on this one? You get 2 and 4, right? If you crisscross, is that correct?
You have to simplify that.
You got to simplify because ionic compounds, all of these are ionic compounds, use the simplest ratio. So it needs to just go, we just know we need 2 of these for every one of those. Okay, you can do that math in your head, I hope. But 2 of these and 1 of those. So that means I need a parenthesis and a 2. So PB CO3 2. I always kind of call this kind of my rough draft, or just my work in progress, and then get the final answer. Any questions on those? We're all good? You guys, again, being quiet on me. All right. We may get done in time for you to be able to do the rest of these. I'm hoping those of you at home watching this are having the same level of confidence. All right, now, if you have the flow chart that I gave to you, okay, it's on the opposite side of the ion sheet. If you have that flow chart, I think it'd probably behoove you to have the flow chart out. Because now when we go to name, there's always one positive thing and one negative thing. Okay, one positive, one negative. So even though this is a very complex, there's all kinds of stuff in here, there's only one positive, that, and there's only one negative, that. Okay? So we just have to be able to name the positive ion first. So first thing we do is the positive thing hydrogen? No. We're going to learn about acids today. So it's not an acid. Is positive thing a metal? Yes, so it's ionic. So what's the next question you have to ask? Does P, or in this case barium, have more than one possible oxidation state?
No.
Because it's an alkaline earth metal, group 2, the answer is no, so you don't need Roman numerals, so you just name the two ions, barium, and what's the name of that long one? C2H3O2. Acetate. Okay, and you get that just by looking. Now, acetate is a unique one. Acetate, as written like on your sheet, C2H3O2. That's just the normal way we write it. Okay, but the structure of acetate looks like this. Okay, and then the extra electrons right there.
So the hydrogen doesn't go into oxygen?
Not in this one, okay? When you make acetic acid, we're going to learn acetic acid, the hydrogen's going to go right here on the oxygen for the acid, okay? But, so sometimes on organic compounds, there's so many different ways they can possibly combine and rearrange as the hydrogen on the oxygen is on the carbon. They give a structural formula, so rather than writing it like that, they'll write it CH3COO minus. That just kind of tells me the 3 hydrogens are attached to the carbon and these 2 oxygens are around this carbon. So that's how it's listed up there on the chart here. It's written in this structural formula. Versus this is just the elements, however many we have, all just kind of listed in the normal order. It's easier to write the formula this way, but this gives us a little bit more idea of how the atoms are actually bonded in it. Okay? It's called a structural formula. Y'all understand that? Especially with organic compounds, when there's so many different ways they can combine, the same formula can combine in different ways. Giving the structural formula helps you to know. So a lot of times, you'll see things written like this, CH3O, CH3. That just means the oxygen's in the middle, the carbon's got the hydrogens on the outside. Okay? This could have the exact same formula. If I had a hydrogen there, it could be the exact same formula as that. C2H6O. C2, there's only one O in here. Okay? So, that's just little tidbits. Number 19. That's a funky L. Al.
Aluminum chloride.
Okay? So here's my positive thing, here's my negative thing. Is aluminum a metal? No. Is aluminum, is aluminum hydrogen? No, it's not an acid. Is aluminum a metal? Yes. Does aluminum have more than one oxidation state?
No.
No. So what does that mean?
It's
What
just
don't you need?
three.
In the name, what don't you need? Roman numerals. Okay? So I'm just going to name the ions. Aluminum, and the positive ion is always just the name of the element. And then you go in your sheet and you see that ClO3 is chlorate. You don't need any prefixes, subscripts, nothing, because there's only one way aluminum and chlorate are going to combine. 21. Here's my positive thing, here's my negative thing. Is the positive thing hydrogen? No, so it's not an acid. Is the positive thing a metal? Yes. Does chromium have more than one possible oxidation state? Yes.
Oh, yes.
The only way you know is you go and you look on the periodic table and you see that it has 3, 6, and 2 written above the symbol. So I have to know which one is it in, 3, 6, or 2. So I have to go with what the chromium is attached to. What's the charge on carbonate from your sheet? Minus carbonate, not hydrogen carbonate.
-2.
Carbonate. -2. Should be -2 on everybody's sheet. Okay? So since there's only one chromium and we know it has to add up to 0, what's the charge on chromium?
2+.
2 plus. So what's the name going to be?
Chromium, the II.
Okay, chromium, Roman numeral 2, in parentheses, then what? Carbonate. And again, you don't have to memorize this. It's given on your sheet. You just got to take the time to look on the sheet. Gives you the charge. So when your metal has more than one oxidation state, you have to look at what it's combined with to figure out what the charge is, what the oxidation state is on that particular metal. But the only time we use the Roman numeral is when it's a transition metal with more than one possible oxidation state. And the only way to know that is to get your periodic table out and just look. Okay? Because not every transition metal has more than one, but most do. So just look. 23. Is the positive thing hydrogen? No. Is the positive thing a metal? Yes. Does iron have more than one oxidation state? Yes, it can be 2, 3, or 6. So again, now I have to look. Sulfur, what's sulfur's charge?
-2.
-2. So the total charge is -6. Therefore, what must be the total positive charge? +6. But because I have 2 of them, each one must be +3. Just for those of you at home, I saw fingers being raised up with the number 3. Okay, even though you're not hearing any responses on the camera. Okay, so what's the name going to be?
Iron sulfide.
Not iron. Iron, Roman numeral 3. And then it's going to just be what?
Sulfide.
Sulfide, because there's no oxygen. It's just going to be a monatomic ion, so it's sulfide. Gotta use the Roman numeral when it's a transition metal with more than one. Notice on barium and aluminum I didn't have to, but on chromium and iron I do. And then lastly, number 25 is copper equal to hydrogen? No, so it's not an acid. Is copper a metal? Yes. Does copper have more than one oxidation state? Yes. So what's the charge on copper here?
1.
+1, right? Because this is -1 because the halogen, so this must be +1. So what's the name going to be?
Copper, I, bromide.
Okay? And it's copper 1. That's just a Roman numeral bromide. Copper 1 bromide. So these seem to be given the most challenge for you, which I kind of pointed out and said that using the Roman numerals is pretty much the hardest part of this whole thing. But you just have to look, okay? Now, let's just practice. If I gave you H3PO4. And I want to know, well, what's the charge, or the oxidation state really is a better term. What's the oxidation state of phosphorus in this compound? Okay, well, what do I know the sum of all the oxidation numbers has that up to? 0. What do we know the charge is always on oxygen?
-2.
-2. We have 4 of them, so it's -8. What's the charge on hydrogen? +1. It only has 1 electron, the only thing it can be is +1. But I have 3 of them, so it's +3. So obviously the phosphorus must be +5. Now that doesn't mean that the phosphorus has is lost 5 electrons. That's why we're going to say +5, not 5+. Okay, and if I want to draw this, if I draw it, I put the phosphorus, the oxygen, well, let me do it this way, I need to show electrons. Phosphorus has 5 valence electrons. So I can put an oxygen here with one of the hydrogens. I can put an oxygen here with another hydrogen. Put an oxygen here with another hydrogen. And then I can put the oxygen here with that coordinate covalent bond where both electrons come from the shared pair. So if you look, phosphorus has 2, 3, 4, all 5 of its electrons involved in bonding. That's what the +5 is telling me. How many of the valence electrons are involved in bonding? That's why we say it's +5, not 5+, because it's not really a +5 charge. It's not losing 5 electrons. It's just sharing 5 electrons. Okay? But we should be able to calculate what that oxidation state is. So if I give you Na2SO3, you tell me, what's the oxidation state of sulfur in this compound? Just don't say it out loud, just figure it out. What is sulfur? Hold up the number of fingers that you think, okay, good. Yes, yes, yes. Okay, everybody got it, good. Okay, so that's +1 times 2 is +2, -2 is -6, therefore it must be +4. Now again, just because I tend to overdo things, I want to just draw again. If I draw this Lewis dot structure, sulfur, oxygen, Na, oxygen, Na, okay? And so now it has 2 lone pair, but we're going to put an oxygen just on one of them. So when we say that, how many of sulfur's electrons are actually now involved in bonding?
6.
1,
No, I'm sorry,
1,
4.
2, 3, 4. Okay? These are lone pair, they're not involved in bonding, they're just there. Okay, it's got 6 valence electrons, but only 4 of them are actually involved in bonding, so it's in the +4 oxidation state. Now, if I said that this was Na2SO4, I put the other one here. By the way, these have lone pair here. If I put the other one there, now how many of sulfur's electrons are involved in bonding?
6.
All 6, and it would be -8, so sulfur would be in the +6 oxidation state. Okay? But because it can share, oxygen will bond with those lone pair doing that coordinate covalent. That's why those nonmetals have more than one oxidation state. They're not really losing more. They're just sharing lone pair with oxygen. That's why the potential oxidation states are always in increments of 2, because it's these lone pair getting shared. All right, I'm just trying to let you understand what the whole term oxidation state means. That's my goal. All right. That's all about ionic bonding. Let me go backwards now, since we're just talking about oxidation states, and fill in the notes. how to determine that. We just did part C, determining the oxidation states. Okay? So the oxidation state, the charge of any element in their natural state is always 0. Okay, so gold, copper, protons equals electrons, the charge is 0. We already kind of knew that. When we talk about a monatomic ion, Na+, the oxidation and the charge are really the same thing, so it really doesn't matter if you say +1, 1+. It's the exact same thing. Because in ionic compounds, it's how many they're actually gaining or losing. It's really in covalent compounds, you're sharing where it can vary, and that's where we need to really differentiate the sign. We just said this, the sum of the oxidation numbers always equals to 0. That's how we figured it out. Whichever one's more electronegative is the one that it gets the negative charge. The less electronegative one becomes positive. That's why chlorine in ClO, chlorine has to be positive. It wants to be -1, but when it combines with oxygen, oxygen's more electronegative in it, so oxygen's negative, chlorine's forced to be positive. So, but that's why those nonmetals can have a positive oxidation state. It's almost always when they combine with oxygen. When they combine with anything else, they're the more electronegative one, they're going to be negative, -3, -2, -1. Okay? And in polyatomic ions, the oxidation number equals the charge of the ion. Shoot over here. Now, so if I look at NO3 minus, and I want to know what's the oxidation state of nitrogen in this ion, well, what do we know oxygen is? -2. We have 3 of them, so it's -6, but this time it has to add up to -1, whatever the charge is on the ion. So nitrogen must be +5. So phosphate is PO4 3 minus, -2 -8 has to equal -3. So phosphorus again must be in the +5 oxidation state.
Is that +5 the most common combining with oxygen?
For fluorine, for phosphorus, yes. Not necessarily, because if it's NO2 minus nitrite, which is real common, it's going to be -2, -4, it's going to be +3. It's just the highest, nitrogen is +3 or +5, the higher oxidation state gets the 8 suffix, the lower oxidation state gets the ike. That's where the 8 and the ike come from. 8's always the higher oxidation state. You don't have to know that, but it's just a freebie for you. Okay, so we just did that. We've already applied these rules. Just wanted to make sure on ions you knew that. Okay? All right, so now let's talk about covalent compounds. So, naming binary compounds. What does binary mean?
2.
Well, I'm going to let you guys can pretty much practice these, and if you want to see the answers, check your answers, we can do that. But, if you want to fill these in, these are just more practice for you on that. All right. Naming binary. Again, I asked the question and didn't listen to the answer. What does binary mean?
2 or something?
2, only 2 elements, okay? And since it's molecular, it's going to be 2 nonmetals. So you might want to write that just out to the side. 2 nonmetals. That makes it covalent. Okay? Now, which one are we going to name first? Positive or negative? Positive. Name the positive, and that's really always going to be the first one. Element using a prefix to indicate the number of atoms. Okay? Use a prefix to indicate the number of atoms in the molecule. And now here's the kicker. If more than 1. We don't start a name with mono. But you will use a prefix, name the negative ion. It's the second one listed. Using the appropriate prefix, including mono. And it's always going to end in "ide." You're going to have an "ide" suffix. So what's the prefix for 1? What's the prefix going to be for 1 that we would use? To what? Mono. I just heard a mumble. What about 2? Die. Not bi, but die. Ooh, that reminds me. I'll come back to that. 3 is tri. 4 is tetra. Okay? As in a tetrahedron has 4 sides. Tetris has the 4 boxes coming down. Okay? 5 is penta. Then hexa, hepta, octa, nona, and deca. Those are just your Latin. You know a lot of those from math already. So these are the easiest ones of all to name and write formulas because you don't have to worry about balancing charge. You don't have to worry about Roman numerals. Prefixes tell you everything. Okay? So now you guys have this, so you can just kind of keep referring to what all this that's written down. Okay? Very simple. So if we want to practice that, examples, well, Si is what element? Silicon. How many, and so I only have 1 of them, so I don't have to use a prefix. And then how many oxygens do I have?
2.
2, so what do I say?
Dioxide.
Dioxide. And they all end in "ide." So what would N2H4 be called?
Nitrogen.
How many nitrogens? There's more than 1 now.
Dinitrogen tetra.
Dinitrogen.
Tetra.
Tetra. Hydrogen hydride. Okay, that one you just kind of have to get used to. The hydride when the hydrogen is in the second one. Now that's also known as hydrazine, which is used in rocket fuels a lot. Okay, so you just use the prefixes. So if I said CO, what's the name of that going to be?
Carbon oxide.
How many oxygens?
Carbon monoxide.
Carbon monoxide, because you use mono on the second one, not on the first one. So this would be carbon monoxide. But CO2 would be
Carbon dioxide.
carbon dioxide. Those are compounds that you've heard a lot. Okay? Just prefixes. You don't have to worry, I just however many of each one there are. You recognize it because the first thing's a non-metal. So then we go the other way. So in this one now, the name of the binary molecular contains prefixes. This is kind of just redundant, indicating the number of atoms of each element present. No prefix, what do you assume? If there's no prefix, how many atoms? 1. Okay? So we just did this one. Carbon monoxide is going to be CO. Carbon dioxide is going to be CO2. diarsenic pentoxide.
Whatever arsenic's letter is.
Arsenic is element number 33, so it's AS.
S2 and then 5 oxygen.
O5. That's all there is to these. They don't get any harder than that. These are the ones you hope that there's just a bunch of these on the test. Okay? Because there's no way to, there's no trick, the hard part of ionic is, do I need a Roman numeral or not, and how do I balance the charges, and all that stuff. All right. So we'll practice some of that on the sheet. You know, I'll give you another practice sheet of things to name. All right. Last one. Naming acids. If the positive ion is hydrogen, what makes an acid is it's got a hydrogen that will be donated in water or ionized in water, and the water steals it off and makes an H3O+. So acids have to have hydrogen in them. Okay? So we look at the positive ion is hydrogen, that's how we're going to recognize it's an acid. If it's a metal or ammonium, it's ionic. If it's a non-metal, it's covalent. So since all acids have hydrogen in them, that means the name of the acid is dependent upon what the hydrogen's attached to. What's the name of the anion? Okay? And if you look on your flow chart, you'll see over on the top right, the ion, and then you'll see the root word of the acid, and then the suffix that we're going to put. Okay? So if the anion H is attached to an I, a chloride, a bromide, a fluoride, a sulfide, a nitride, any ide ion, the name begins with hydro. You put the root word of whatever the nonmetal is and add an ic suffix. So I look here. So what's the name of that ion? Cl minus. Chloride, right? So that's the chloride ion. Therefore, I'm going to say hydro, chlor is the root word, ic, acid. So S is what the name of what ion, if it's just S? Sulfide. So the name of the acid is going to be?
Hydrosulfuric acid.
Hydro, no prefixes or anything, just hydro. And we want to say sulfic. It makes more sense to say sulfic, but for some reason they've left the UR in there, and you just kind of have to get the feel of that. But it's hydrosulfuric acid. Hydrosulfuric acid. So what would the number 3 be? Say that again, Lana. Hydrofluoric acid. And if anybody watched Breaking Bad, I don't know if you've ever seen Breaking Bad. There's a whole part of a show where they killed a drug dealer and they were trying to get rid of the body, and they try to dissolve. Well, they do dissolve it, and it doesn't really happen. But in the movie, in the show, it did. It dissolved in hydrofluoric acid is what they used, and it's a funny scene. Anyway.
Isn't hydrochloric acid mustard gas? Or no?
No, just chlorine gas itself is mustard gas. This is also known as muriatic acid, which people use in the swimming pool to adjust the pH. It's also what's in your stomach. It's a HCl, it's a strong acid, which is if you have the unfortunate experience of throwing up, it burns because of the presence of the hydrochloric acid in your gastric juices. Okay, so now notice the spelling of fluorine, hydrofluoric acid. It's UO, not OU. If it was OU, it'd be flour, like you'd bake with. Okay, so if it ends in I, it's hydro. But when the anion of the H plus is attached to ends in ite, that means it's a polyatomic ion, so we're not going to use hydro now. Now we're only going to use the name of the root word. Okay, so sulfite, and we're going to put an OUS ending on it. So we're just going to say sulfurous acid. So the nitrite, if I get that, I'm gonna move it up so we can see the rest of it. Okay, sulfurous acid. So what would this one be? If it's the nitrite ion, what's the name of this acid gonna be? Nitrous acid.
Oh, that's NOS, isn't it?
No, NOS, I think is the same as laughing gas, which is just N2O.
Oh, it's into.
N2O, it's not an acid. Okay? Now, if it ends in 8, if the anion ends in 8, you just change it to ic. And the way I remember this, if you go to the cafeteria, generally if you ate something, you go ic. Okay? And so 8 goes to ic, I goes to us. So, now hey, there's typos right here. Typos on this. I've corrected it, but it was too late, it was already posted and everything. So this is really sulfate, not sulfite. And this is nitrate, not nitrite. These are right. The name was wrong. Okay? So if it's sulfate, what's the name of the acid going to be?
Sulfuric acid.
Well, sulfuric.
Sulfuric acid.
And so then HNO3, nitrate, is going to be
Nitric acid.
nitric acid. 8 goes to ic, 8 goes to us. Woo, time keeps on slipping, slipping, slipping into the. Hey, you guys understanding this? So it's all about the name of the anion. Okay, and it's everything you need is in the top right part of that flow chart. Now let's just go the other way real quickly, then we'll be done. All right, so if we're going to write the formulas, we have to look at the formula in charge of the anion. It's all about the anion. Then you add hydrogens to make it neutral. So hydrofluoric acid means that the acid is binary, hydro. Since it's hydrofluoric acid, what anion must it be attached to? The fluoride, right? Which we know to be F minus. So how many hydrogens do I add to make that neutral? Just one, because each hydrogen is plus 1. So HF is going to be the formula for hydrofluoric. So what would be the formula for hydrobromic acid? HBr, because bromine is over here in the halogens, so it's just going to be HBr. Then if I even said one more, hydroselenic acid. Selenic. Well, you come over here, selenic came from selenide, selenium. So it's Se, so what's the charge on Se? -2, so what's the formula of the acid going to be? If it's S2 minus, how many hydrogens do I add to make it neutral? 2, so it's H2S. Okay? So it doesn't matter what it is. Hydro just tells me it's just that there's just a non-metal. Whereas if it's phosphoric acid, what anion is it going to be? Phosphoric came from which anion? Which one?
Phosphite.
No.
Not phosphite. Phosphate.
8 goes to ic, 8 goes to us, so it's phosphate.
Phosphate.
Which you go and you look on your sheet, you see that it's PO4, 3 minus. So what's the formula of the acid going to be? What's the formula of the acid going to be? No, it's -3, so how many hydrogens I have to add? 3. Don't make it complicated. It's H3PO4. The positive thing is always hydrogen. If it's -1, you add 1 hydrogen. If it's -2, you add 2 hydrogens. -3, you add 3 hydrogens. To make it neutral. And then chlorous acid came from which anion? Chlor, what's the suffix? Ite. Which then you go to your sheet and you see that that's ClO2 minus. So what's the formula of the acid? HClO2. Okay? And that's the bell, and that's the end of the notes. So that's all we got to do now is just practice some more. Okay? I'm going to post a practice sheet. I'm probably going to ask you to do some of it over the weekend. Not much. And then on Monday, we're going to kind of go over everything. Tuesday, we're going to do a lab in class. You guys are going to do it virtually at home. And then Wednesday, work on practicing and whatever. And then Thursday, you're going to have a test.